from the first principle, determine y equals 2x squared plus 3x plus 5. So dy dx for this equation, dy dx for this equation will give 4x plus 3. So this is the answer that we expect when we differentiate this equation using the first principle. So the formula for the first principle equals f of x prime equals to limit of h as it approaches to 0, f of x plus h minus f of x, everything divided by h. So in our equation, 2 is f, and then 3 also is our f. Then the x remain to be x, and then in equation 2 we still have x. So what we have as y equals 2x squared plus 3x will now be occupied or be replaced by the formula, because 5 is not a function of x, and therefore that one will not be used in our equation. So limit of h as it approaches to 0, we fit the formula here. We will have f of x plus h minus f of x, everything divided by h. Then we add this now, f of x again plus h, we minus f of x, everything divided by h. So we fit our data on the equation, and therefore we will have 2x plus h squared. Remember, this is squared because x is squared, minus 2x squared, everything divided by h. Then we add 3x plus h minus 3x, everything divided by h. So when you open the brackets in this equation, we will have limit of h as it approaches to 0 as 2x plus h, it is squared. So we will have x plus h, then we multiply again x plus h minus 2x squared, and then everything divided by h. Then we add 3x plus h minus 3x, everything we divide by h. So in this equation, we will open the bracket xh and xh, and then we will have this equation s. So let me multiply it here. So we have 2 x times x, we will have x squared plus h times x, so we will have xh, and then h times h, h times x again plus xh, then plus h times h, so you have h squared, then minus 2x squared, 2x squared. So this one we divide by h, and then we add the second equation plus 3x plus h minus 3x, everything divided by h. So we open the bracket. First of all, we did what is in the bracket, and now we have limit of h as it approaches to 0, will be 2x squared plus xh plus xh will give us 2xh plus h squared, close the bracket, minus 2x squared. Everything we divide by h. Then we add, open bracket, 3x plus 3h minus 3x. Everything we divide by h. So in this case, we also open this bracket, and then the limit of h as it approaches to 0, we open bracket, we have 2x squared plus 2 times 2, because we are opening the bracket, 2 times 2 will have 4xh plus 2 times h squared, that is 2h squared, and then we have minus 2x squared, then plus 3x plus 3h minus 3x. Remember, this is divided by h, and also everything here we divide by h. So 2x squared minus 2x squared, so this one cancels out because it's a subtraction, and then 3x minus 3x, also that one cancels out. So our equation, limit of h as it approaches to 0 will be 4xh plus 2h squared. Everything we divide by h, then we add 3h over h. So in our equation, h is common, so we can remove h outside. So we have h 4x plus 2h, and then I'll divide by h, then plus 3h over h. So this h cancels out, and this h cancels out. So our equation remains to be 4x plus 2h plus 3. Remember, the limit of h is a very small value and it approaches to 0. So we will have 4x plus 2, h is a very small value, so it is 0, multiplied by 0 plus 3. So this one will give us 4x plus 3 as our answer when we differentiate 2x squared plus 3x using the first principle. So the answer that we get here, 4x plus 3, is the same answer we got when we differentiated directly over dy dx. Thank you, and kindly subscribe to my channel. Join me in my next example.